Good morning. Let's see what actually discrete Fourier transform. Frequency domain representation of a sequence x of n by samples of its spectrum x of omega is known as discrete Fourier transform. Figure shows x of omega is sampled by n number of samples and the range taken is from 0 to 2 pi. So DFT can be applied only to finite length sequence. Consider sequence x of n and its spectrum x of omega, which is sampled periodically in frequency by del omega spacing between successive samples. Consider capital N equivalent equidistant sample in interval 0 to pi. So which will give Wk value equal to 2 pi k by capital N. So these are different Fourier transform equations depend on which signal we are using as an input. First, continuous time Fourier transform, that is called CTFT. So capital X of omega is equal to integration minus infinity to infinity x of t into e raised to minus j omega t dt. As we are using here continuous time signal x of t, it is known as continuous time Fourier transform. Next, discrete time Fourier transform, where capital X of omega is equal to summation n ranging from minus infinity to infinity x of n into e raised to minus j omega n, where n ranging from 0 to capital N minus 1. Discrete Fourier transform, that is DFT, x of k is equal to summation n 0 to n minus 1 x of n into e raised to minus j 2 pi k n by n, where k ranging from 0 to n minus 1. We'll see what is the difference between DTFT and DFT. So next formula is for inverse Fourier transform. If it is continuous signal, then x of t is equal to 1 upon 2 pi integration over the range minus infinity to infinity x of omega e raised to j omega t d omega, and x of n is equal to 1 by capital N summation k 0 to n minus 1 x of k into e raised to j 2 pi k n by capital N, where n ranging from 0 to n minus 1. So now let's see the difference between this DTFT and DFT. So here figure represent x of n continuous time sequence. Second figure represent Fourier transform, but as frequency is continuous, it is a DTFT, discrete time Fourier transform, and when we sample this DTFT, we will get DFT, that is discrete Fourier transform. So just check the formula of DTFT. It is x of n into e raised to minus j omega n, where omega is continuous, but when I write formula for a DFT, this omega is replaced by 2 pi k by capital N, that we are sampling that continuous time frequency. So discrete Fourier transform is x of k is equal to summation n 0 to n minus 1 x of n into e raised to minus j 2 pi k n by capital N, where k ranging from 0 to capital N minus 1. Inverse discrete Fourier transform, that is IDFT, which is given as x of n is equal to 1 by capital N summation k 0 to n minus 1 x of k e raised to j 2 pi k n by capital N, where n ranging from 0 to n minus 1, where k represent index of frequency axis and small n represent index of time axis. Now, as this chapter is having examples of DFT where we have to use different exponential formula, so for that we should know trigonometric values. So let's just see a shortcut method to find out angle values. So first represent angle in degree 0, 30, 45, 60, 90, 120, 135, 150, 180. In radian 0, pi by 6, pi by 4, pi by 3, pi by 2, 2 pi by 3, 3 pi by 4, 5 pi by 6 and pi. Now for calculating these values we can use scientific calculator, but if we want to do it fast, what is needed, we have to make this table. Now if I consider value of sine from 0 to 180, just check what we did. root 0 by 2, root 1 by 2, root 2 by 2, root 3 by 2 means 0, 1, 2, 3, 4, then 3, 2, 1, 0. So after simplifying this row, we'll get values sine of 0 equal to 0, sine of 30 is equal to half, sine of 45 equal to 1 by root 2, sine of 60 equal to root 3 by 2, sine of 91. Like this we can complete this row. So in case of cosine, what we have to do? Just write 4, 3, 2, 1, 0, 1, 2, 3, 4. Just sign gets changed in second and third quadrant. So similarly we will get values of cosine, and we will take ratio of sine and cosine, we will get tangent value. Now just for revising concept, we are saying for first quadrant sine cosine are positive, for second quadrant sine is positive, cosine is negative, for third quadrant sine cosine both are negative, and for fourth quadrant sine is negative and cosine is positive.